In this data structure class, we will see the bubble sort from third unit, searching and sorting. In this class, we will see the need for sorting and the bubble sort definition. After that, let us see some of the example for this bubble sort with algorithm and the advantage and disadvantage of bubble sort. First, let us see what is bubble sort. Bubble sort is a simplest algorithm which is used to sort or order the list of values by comparing the neighboring elements repeatedly by swapping their positions if necessary. Okay, so this is called as bubble sort. Bubble sort means the largest value is bubbled to its right position. That is, every iteration, the largest position, wherever it may be initially, that will be reached to its right position. Okay, so this is called as bubble sort. Let us see how the bubble sort is actually working. See, in the first iteration, that is compare and swap iteration, the step 1, starting the first index, that is the searching will start at the first index and compare the first and second elements. Okay, in the data item, first it will select these two data items and compare. If the first element is greater than the second element, then they will be swapped. Okay, suppose this is 4, this is 2, then these two items will be swapped. And now compare the second and third items. Second and third items will get compared. Okay, and if it is required, then they will also be swapped out. The above procedure will be repeated until it reaches the last element. Until it reaches the last element. Okay, and this is the second iteration, that is remaining iteration. All the iteration, the same process will goes on the remaining iteration. Okay, see, in the first iteration, the largest element reached its right position. In the second iteration, the second largest item will reach its right position. Okay, that is, after each iteration, the largest element among the unsorted element is placed at its right position or at the end. Okay, and the third iteration is repeat until all elements to be sorted. That is, in each iteration, the comparison takes place up to the last unsorted element, and the array is sorted when all unsorted elements are placed at their correct position. Let us see one example for this. So the bubble sort is bubbling the largest element to its right position. Okay, that is, which is the largest item in the given data set, and that item will be located in its right position. So this is called as bubble sort. Okay, let us take this example: 77, 42, 35, 12, 101 and 5. Okay, in this, the first two elements will get taken and these two elements will be compared: 77 and 42. Here, 77 is the largest element and 42 is the smallest element. Okay, and these two items should be swapped. Okay, 42 and 77, right? And now next two items will be taken out: 77 and 35. Here 77 is greater and 35 is smaller, hence these two items should be swapped out. Okay, we need to swap 77 and 35. Okay, now in the first position 35 is placed and in the second position 77 is placed. And next step, let us take uh, these two items, 77, that is the 77 and 12. Okay, here 77 is greater and 12 is smaller, hence we need to swap these two items. Okay, swap 12 and 77, right? And next let us take these two items. Now 77 and 101. Okay, here 77 is smaller than 101, hence no need to swap these two items. Okay, and next let us take 4 and 5. Okay, fourth position and fifth position. Now 101 is greater than 5, hence these two items should be swapped out. Okay, swap 105, 5 and 101. Okay, now the largest value 101 is placed in its right position. That is 101 is bubbled to its correct position. Okay, let us see another example for this bubble sort. Okay, sort the given values 7, 2, 9, 6 and 4. Okay, in pass 1, compare the first and second elements starting with the first index. Okay, these two elements will be compared and 7 is greater than 12, then we have to switch 7 and 2. That is swap these two items. 2 and 7 should be swapped out and 7 should be compared with 9. Okay, no need to swap because 7 is less than 9. Okay, so no need to swap. Now 9 is compared with 6. Okay, 9 is greater than 6, then we have to swap these to 6 and 9, right? And the next step, 9 should be compared with 4 and 9 is greater than 4, hence these two should be swapped out. So in the first iteration, 9 is placed in its right position because 9 is the greatest data item, right? And in pass 2, the same will be repeated until this one. Okay, 2 and 7 we need to compare. No need to swap because 2 is less than 7. Okay, and next step we can take 7 and 6. Okay, here 7 is greater, 6 is smaller, then we need to swap these two items. See, 6 and 7. Now we need to compare 7 and 4. Here 7 is greater, 4 is smaller, then we need to swap these two items. See, 4 will become here and 7. That is 7 is the next largest item. Now at the end of second pass, 7 is placed in its right position. Okay, and in pass 3, now 2 and 6 will be compared. So 2 is less than 6, then no need to swap these two items. Okay, and next we need to compare 6 and 4. Here 6 is greater than 4. Now we need to swap these two items. We have to swap these two items. So now the next greatest item 6 is placed in its right position. Okay, at the end of pass 3, third greatest item is placed in its right position. And now this is pass 4. Here all the data items are sorted here. So there is no need to exchange all the items. The data items are sorted. And this is the algorithm for bubble sort. In the bubble sort, uh, the parameter is array, unsorted data items array. Okay, this array contains unsorted data items. For I equal to 0, I less than a dot length I plus plus. That is the this is array index. I indicates array index. Okay, and next another index is that j, which is used to compare the neighboring data item for every iteration. Okay, j equal to 1. I is starting from 0, but j is starting from 1 and j less than a dot length minus I and j plus plus minus I, because at the every iteration the greatest item will be placed in its right position, so we need not to reach there. So every iteration one will get reduced, right? And if a of I minus 1 is greater than a of j, That is A of j minus 1 is greater than A of j. Then we need to swap these two items. Okay. So the same thing will be repeated until all the iterations will get completed. Hence, we get the final sorted array. Advantages of bubble sort. Bubble sort is very simple sorting technique. It requires very minimum memory, that is very little memory. And it is easy to implement. It requires very few lines of code. Okay, only two for loops, right? And with the best case, the runtime complexity is order of n. The bubble sort is very much helpful in determining whether or not the list is sorted. Okay, in both the cases, we can implement the bubble sort, right? So these are the advantages. And next, let us see the disadvantages of bubble sort. This algorithm is very slow. It takes more time for sorting. Okay, it requires very less space, but it consumes very long time for sorting. Okay, and it is suitable for smaller data set. If the data set is high, then we cannot implement bubble sort. The time complexity is order of n square, right? So far we have seen the bubble sort in third unit searching and sorting, and here we have seen the bubble sort definition and the algorithm for bubble sort we have seen with some example. After that, we have seen the advantages and disadvantages of bubble sort. In the next class, we will see another important sorting technique from third unit. Thank you.